I'm going to demonstrate the process of using VMware SIOC from CloudStack with SolidFire. So here I am in the Infrastructure tab. I just have a single zone, single pod. I've got a couple clusters, one of which is a vSphere cluster, and each of my compute clusters has two hosts. So I have two ESX hosts in my vSphere cluster. Let's go to primary storage and click on the View All button. And in the upper right, we'll click Add Primary Storage. Now here we want to have cluster scoped primary storage. I just have the one zone, the one pod, and I'm going to pick my VMware cluster. I'll provide a name here. Let's do SolidFireShared 1. For the protocol, I'll select Custom. In the drop-down, I will pick SolidFireShared. This is the SolidFire plugin that allows you to have multiple virtual disks on the same data store, and that data store is backed by a SolidFire volume. All right, so for the bytes, I'm going to pick I'm going to pick a terabyte. And I have this over in a separate document since it's a pretty large number, since the GUI is asking for this in bytes, not gigabytes. So this big number I just pasted in is 1 terabyte. So that will lead to, when I create this primary storage, we will have a SolidFire volume that's a terabyte in size, and the min IOPS of our SolidFire volume will be 5,000. And this URL field, now this is a collection of key value pairs that are vendor specific. What I have, again, is in that same document, I've gone ahead and put this information. Let me go ahead and copy it. This contains information like the management virtual IP address of the SolidFire cluster, the storage virtual IP address of the SolidFire cluster, administrative privileges, so when we want to create volumes or accounts, we can do that through the control plane with SolidFire. And then it specifies the min, max, and burst IOPS that we'd like for our SolidFire volume. The only trick here is that this min IOPS, which we have set at 5,000, that needs to equal, and I'll go back to the the CloudStack GUI, that needs to equal the capacity IOPS value. So with that in mind, I'm going to go ahead and paste this in, and I'm going to fix that there. This last part is for VMware, we need to specify which data center is where we're going to house the data store that is created. Now for the storage tags, I'll use something very similar to this. We could use the same exact string, but let's just use something a little bit slightly different. Now you might, perhaps in a production environment, maybe this would be your, you might say SolidFire-Gold or SolidFire-Silver or something like that. This is how we're going to identify from our compute offering where we want the virtual disk placed. So keep in mind here we said SolidFireShared A. I'll go ahead and hit the OK button. Now right now we're going to see on the SolidFire cluster, if I switch over to its GUI, if I hit the refresh button, we'll see a SolidFire volume has been created with 5,000 min IOPS, 50,000 max, and 75,000 burst. The size is a terabyte. And here is the name. It's named, in this case, the same as the primary storage that we're creating in CloudStack. Now let's go over to vSphere Client, and we can see here within the vSphere Client environment, we'll just kind of point out I have my two ESX hosts. And if I switch over to the data stores view, I'll highlight it. This data store was just recently created. So first, we automatically created a SolidFire volume with the right size and performance characteristics. Then through vSphere, we went ahead and created a data store on that SolidFire volume. If we just take a quick peek inside of it by browsing the data store, we can see there's really not much in here right now, just a single private folder. Okay, so this should be ready if we go back to the CloudStack GUI, which is over here. Okay, we can see that this primary storage was successfully added to CloudStack. Our next step as an administrator is to create compute and disk offerings. Let's just start by making a compute offering. For that, we'll go over to the service offerings tab. I'll click on that. I don't have any compute offerings at the moment. In the upper right, I'll click on Add Compute Offering. Now let's give it some name like SF for SolidFire CO Compute Offering 1. And maybe the description can be SolidFire-Shared-1. I'm going to go ahead and just copy that as I'll use it in just a moment somewhere else. CPU cores, I'll do 1, say 200 megahertz, and 128 megs of RAM. Now the storage tag here that I'm pasting in, we're actually doing this as our way of tying this particular compute offering into the primary storage that we just created. So actually, if I just go ahead and get rid of this and type in S, we can see here there's a couple storage tags that the system knows about. Now we just created our SF-Shared-1 primary storage, and for it we provided a storage tag of SF-Shared-A. So that's what I want to select here. So what this amounts to is when we spin up a VM that makes use of this compute offering, and not only will we have these particular settings for the CPU and memory, but when CloudStack looks for a place to store the virtual disk of this VM, it will go through all of our primary storages in the applicable zone and see which ones describe themselves through their storage tags as SF-Shared-A. In our case, we only have 2 primary storages in this zone, just have the one zone anyways, and the SolidFire primary storage that we just created is the only one that describes itself with this storage tag. So CloudStack's choice will be pretty easy. It will pick that particular primary storage and then go ahead and use the SolidFire plugin that supports that primary storage. So let's go ahead now and hit the OK button. And we'll see here our compute offering has been successfully created. Now we can go ahead and click on the Instances tab and create a virtual machine that makes use of that compute offering. In the upper right, I'll click on the Add Instance button. I'll let that template selection be and click on the Next button. I only have one vSphere template at the time being, so I'll just go ahead and leave that one selected. Let's make its root disk 100 gigabytes. I think for this particular template, the root disk is only 2 gigabytes by default, so I'm going to go ahead and make that a bit larger. And now I'll click on the Next button. We just have our one compute offering, so we'll just hit the Next button. We don't have any disk offerings right now. Disk offerings are templates for additional data disks, but the principle as far as storage is very similar. We would just create a disk offering. We could provide a size for disks that we'd like created from that disk offering, and then we'd provide a storage tag to associate what primary storage or primary storage is if you have multiple that describe themselves the same way. where we'd like that virtual disk placed. So it's a very similar concept from a storage standpoint to how the root disk behaves with respect to a compute offering. I'll just go ahead and hit next. We don't need to worry about affinity groups. Networking is fine. SSH key pair is fine. Let's go and put a name in here, VM vSphere 1, and then click on the Launch VM button. So right now, CloudStack is looking through the compute offering. It sees what the storage tag is. It's SolidFireShared 1. It'll look through its list of primary storages for the applicable zone. It'll find our primary storage that we recently created, and then it'll make use of the underlying SolidFire plugin to interact with that particular primary storage. So if we want to, we can go over to vSphere Client, and we can see there's some activity here. Right now we're actually deploying the OVF template to the data store. And let's just go ahead and right-click on that data store, Browse Data Store. So we can see there's some additional stuff in here. Before we only had this one private folder. Now we have another folder with our template in here. I believe there's going to be 6 files that show up. Yes. And then we cloned that when we created the VM that made use of this template. We cloned that for use for our new VM. So at this point, we can just exit out of here. In a moment, this virtual machine should be up and running on the cluster. Now we can see it actually just powered on the virtual machine. Now, if we want, we haven't actually done anything with SIOC at this point. We could have, as soon as we created primary storage that was based on the SolidFireShared plugin, we could have gone over to our data store, and within this particular view we could go to configuration, and here we can see in the properties of this particular data store that storage I/O control is not on by default. It's not enabled. All we need to do is click on this particular checkbox and then close this dialog. So now storage I/O control is enabled on this particular data store. So that's a good first step. CloudStack, though, natively, CloudStack does not know about SIOC. So any virtual disks that CloudStack creates on vSphere have the default SIOC settings. Let's take a look and see what that amounts to. If I go back to our hosts and clusters view, I'm going to go ahead and right-click this, edit settings. It's going to pop up a dialog here because I can't quite edit all of the features with this particular client I'm using, but that's fine. I'll just hit the OK button in this case. If we take a look at our hard disk, which I've selected, we can see it's 100 gigabytes, which is good. That's what we asked CloudStack to make it. If we go over to the Resources tab and click on Disk, we can see some SIOC settings. The two that are of interest to us the most are the shares value, which is by default set to 1,000, and the limit IOPS, which is by default set to unlimited. So these are what we're going to go ahead and manipulate with the SIOC plugin for CloudStack. It's a plugin which extends CloudStack's standard API. So it extends it with one new API command. And this is how we'll be able to manipulate the SIOC settings of our virtual disks from CloudStack. Let's go ahead now and see how we actually change these settings dynamically. Oh, and one thing to point out before we get to that, if I switch back to the Hardware tab, you can see for this hard disk that the it's a SCSI disk. And that's important if you want to make SIOC changes to a disk that's attached to a running VM. And I would think in the vast majority of situations, that's what we're really looking at doing here. The way we make sure that we're actually using a SCSI disk for the root disk, so by default the data disks are SCSI disks, but on VMware the root disk is normally an IDE, normally makes use of an IDE controller. We want to make sure it's using a SCSI controller. Let me cancel out of here, switch back to the CloudStack GUI. In the global settings, if we take a look, we'll search on controller, and we can see here VMware root disk controller. I have it switched from IDE to SCSI, and that's important if we want to be able to dynamically update the SIOC settings of that disk. So this is what I have already configured. And now with that in mind, let's go ahead and switch over to a window where we can see the command that I issue to the CloudStack SIOC plugin to make these changes. So let me start from the beginning here. We on the very far left of the command, we can see that we're making use of the CloudMonkey CLI for CloudStack. Within that, we invoke the update SIOC info functionality. So if I switch over to a web browser, we can see on the far right here, there is documentation on this, just like the other CloudStack API commands. So it's called update SIOC info. You pass in a zone ID, the ID of your storage, how many shares per gigabyte you'd like the virtual disk to have, what the limit IOPS per gigabyte for the virtual disk should be, and if you want to be notified if the cumulative limit IOPS is above some threshold, well, this is actually a required field, but if you're not interested in it, you can just put in a really, really high number. But if you are interested in using that, then put in a number above which you'd like to be notified. And what happens there is it's just when you execute the command, instead of just coming back with a success message, it will let you know that you are above that threshold. And that might be an indication that it's time for you to move some of those virtual disks from the current primary storage that they're on to one that's less heavily utilized. So let's just explain some of these. So shares per gigabyte. Shares is the way that VMware SIOC balances out who gets attention, which virtual disks get attention. Let's use as an example, if you have two virtual disks and they each have 2,000 shares, that means there's 4,000 shares on the data store. So each of those virtual disks would get half of the attention of that data store, assuming that both of those virtual disks are being heavily utilized. The performance of the data store will be split evenly across them because each has 2,000 shares divided by 4,000 total shares on the data store. Now let's say maybe you add another virtual disk, so you have 3 of them now. The first 2 each have 2,000 shares. Maybe we say the third one has 4,000 shares. So that means now that the data store itself has 8,000 shares. That's our denominator. A given virtual disk is going to be whatever number of shares it has. That'll be the numerator. So for our first virtual disk, it was 2,000 shares. Now it's divided by 8,000 total shares. That means that virtual disk would get 1/4 the performance of the data store. And the same story for the second virtual disk, which also had 2,000 shares. Now our new virtual disk, we said that had 4,000 shares, and that's divided again by 8,000, which is the total number of shares of our data store. So that third virtual disk would get half of the attention of the data store. And that is really in times of contention. So if we're maxing out our data store and VMware has to make decisions about what virtual disks to give attention to, that is how it does that kind of thing. Now the other parameter that we pass in here, limit IOPS, that is essentially rate limiting on a virtual disk. So we can pass in a certain number, maybe we say 100 IOPS per gigabyte, just to keep it simple. If you had a 10 gigabyte disk, that would be 1,000 IOPS you would be limited to. By default for VMware, that an I/O operation is considered a 32 byte operation. 32 kilobyte operation. So if you, for example, issued a 64 kilobyte I/O, that would be, if you left the defaults at play, a 64 kilobyte I/O divided by 32 kilobyte boundary means that that would cost you 2 of your I/Os. So if you had, in this example, a 10 gigabyte volume and 100 limit IOPS per gigabyte, we would give you a total of 1,000 of those I/Os per second. And if you just a moment ago issued a 64K I/O operation, dividing that by 32, that cost you 2 of your 1,000 limit I/Os in that second. So that's how that works. Now let's go ahead and execute this from CloudMonkey and see what happens. So we've got CloudMonkey as the CLI, update SIOC info as our command. The zone ID, I actually already have this filled in properly. The storage ID is actually left over from a previous example, so we'll have to go ahead and update that. Let's switch back to the CloudStack GUI, to infrastructure, primary storage, SolidFireShared 1, and we'll go ahead and copy this ID. It's sort of an unusual looking ID. It's basically the IQN of the iSCSI volume. Let's go back to our command line interface, and I'm going to go ahead and erase that storage ID and paste in the new one. Now the shares per gigabyte, let's do 10. Well, let's do 20. 20. So 20 times our 100, right? So we should have 2,000 there. We can leave, well, let's do limit IOPS. We can put that to 100. And notify threshold, I have that at 10,000 right now. That's fine. Let's go ahead and execute this. And in just a moment, oh, we can actually see here our IOPS notify threshold was exceeded. I didn't actually do the calculations there, but let's see, limit IOPS per gigabyte was 100, and we had a 100 gigabyte volume. And yeah, it ended up calculating that to 10,737. Yes, the reason is because we don't actually have an exact 100 gigabyte volume. It's actually done in Gigabytes. And so when we queried CloudStack's database to see how large that database, how large that virtual disk is, it didn't come back with really 100 gigabyte volume. It came back with 100 gigabyte volume. And then we asked for that in bytes, and so it ended up being that it was larger than just when we do the math, it's larger than just 100 times 100 shares per gigabyte. It ends up being, what would it be, about 107 times 100 limit IOPS per gigabyte. So in any event, we actually ended up exceeding our threshold that we're comfortable with. So if this were actually happening in the real world, you might think I possibly need to migrate some of my virtual disks from this data store to another data store that's less heavily utilized from a performance standpoint. Now in this case, just for demonstration purposes, I really just have that one virtual disk on here, and we're not in any kind of a performance situation. It's not an issue, so we'll just ignore that particular message. Let's go and actually see now from vSphere Client what effect this had. So we'll go over to my Windows VM. I'll right-click on this virtual machine, edit settings. Just going to go ahead and hit the OK button on the resultant dialog. Click on my hard disk, go to Resources, click on Disk. We can see now we are at 4,000 shares. And as the message mentioned, we're at 10,737 limit IOPS. So this is exactly as we would have expected. Let's go ahead and cancel this, switch back to our command prompt. I'm going to hit the up arrow to bring the command back. Now let's take our limit IOPS and change that. Let's make it 50. Now in this case, I'll hit enter. In this case, we should just simply see a success message. Yeah, there we are. We did not exceed the IOPS notify threshold value. Let's go back to vSphere Client and take a look at the change there. Edit settings, hit OK. Select my hard disk, click on the Resources tab, the disk row, and now we can see we're at 5,368 limit IOPS. But we didn't change the shares value, so we're fine there. And as a performance optimization too, we can see, so if we see here, actually, I don't know if reconfiguring virtual machine has actually been executed twice because we did change the virtual disk settings associated with this virtual machine. Now, if I go ahead and just rerun this command, we'll just see a success message come back. If we go to vSphere Client, we can see that there is no additional change. I should say there's no additional message here because we realized that nothing changed and no message needed to be sent to vCenter server to update those SIOC settings. So let's say you have a data store with 100 virtual disks. The message I guess I'm trying to get across here is that we perform an optimization such that maybe just 10 of those virtual disks have actually changed since last time. We'll just go ahead and send messages to vCenter server for those 10 virtual disks. The other 90 that didn't change, no need to communicate anything to vCenter server for them. So in general, this is the way SIOC works in CloudStack, and it works the same way for data disks as it does for root disks. Let's go ahead and demonstrate that. I'll click on the CloudStack GUI, go to Service Offerings, select Disk Offerings, upper right, Add Disk Offering. Let's say SolidFireShared 1. And let's copy, well, actually I don't even need to do that. Let's just put an S in here. SolidFireShared A is the storage tag that we're using for this disk offering. So the only primary storage that we currently have that can satisfy this storage tag is the one primary storage that we created at the beginning of this video. Now let's say that particular primary storage is getting close to full. You can make another one just like it if you like and give it the same storage tag, and then CloudStack can choose between those two primary storages that have the same storage tag, or 10 or 20 primary storages that have the same storage tag. And CloudStack has a variety of mechanisms for how it can choose those, and in the extreme case where none of those are to your preference, you can even write a plugin for CloudStack to help in that selection process. Let me just put in some dashes here to be consistent with how I named the other one. We will call this one SolidFireShared A. I'm just going to name the description the same as the storage tag, but in reality you probably would use something that makes a little more sense in your environment. Let's go ahead now and make this maybe 300 gigabytes. So now we've got we will in a little while have our 200 gigabyte root disk, and then we will create a data disk based on this disk offering, which is 300 gigabytes. So about 500 gigabytes of our terabyte SolidFire based data store will be consumed. But at this point we're just creating the template for those data disks. This is all we need. We'll just go ahead and hit the OK button. Once this is created in a second, we can switch over to the Storage tab. And in the upper right, we'll click on the Add button. Maybe give it a name like vol-1. We just have one disk offering, so our catalog of disk offerings is pretty small, just the one disk offering. We'll go ahead and select that and click the OK button. Now this does not actually create the virtual disk within the vSphere environment. This just puts the information for the virtual disk in CloudStack's cloud database in its volumes table. To actually initiate the creation of the virtual disk, we need to attach the virtual disk to a VM for the first time. Let's go to the Quick View column, Attach Disk. We just have our one virtual machine. Let's go ahead and hit the OK button. If we switch over to vSphere Client, we should see some interesting stuff going on here, some reconfigures, and in just a moment, looks like it's done. If we go back to CloudStack, we can see in the notifications area at the bottom, we have successfully attached this disk. I'll close out of that notifications dialog and switch back to vSphere Client. I'm going to right-click the virtual machine, edit settings, again just dismiss through this dialog. And we can see here now, not only do I have my original hard disk, which serves as my root disk, and it's 100 gigabytes, we have a second one which is 300 gigabytes. Also, as we can see here, it's a SCSI device. If we go into Resources, under Disk, we can see for this particular one, it's 1,000 and unlimited. So 1,000 shares, the default, and unlimited IOPS. Now the top one is for our root disk. And we can actually see here if we expand these, hard disk 1 and hard disk 2. So let's say we want to go ahead and change the shares value and the limit IOPS value. Just go ahead and cancel out of that. Let's go back to our command prompt. Now we can see here, all we have to do is actually rerun this command. This command is saying within the selected zone, there is a primary storage with this unique identifier. We're telling the SIOC plugin within CloudStack to go look at all of the virtual disks within that primary storage and set up their shares to be in line with this parameter and their limit IOPS to be in line with that parameter. Now for our virtual disk, our root disk, that will not require any changes. Nothing has changed on that. The root disk is still the same size, which means it would get the same shares and the same limit IOPS because we're passing in the same values that we did last time. Now our data disk is new and we haven't actually run this command yet, so that is what's going to be updated here. I'll go ahead and hit the enter button. And in a moment, we can see, and it makes sense, we actually are well above our notify threshold. It's no big deal in this particular case, but it's just interesting to see. And if we go back over to vSphere client, right-click on the VM, edit settings, click the OK button, go and take a look at resources, disk. We can see here that we do have 4,000 as the shares value and limit IOPS is around 16,000. So I should also point out there are share values there are certain value ranges that are valid for SIOC shares. You must be from 2,000 to 4,000 inclusive. So if we run the numbers and you are above 4,000 shares, you will just get 4,000 shares. At a minimum, you would get 2,000 shares. So in this particular case, let's take a look and see. We'll go back to our command line. We're saying 20 shares per gigabyte. So let's see, that's about we had a 300 gigabyte volume, so that's 6,000, right? There should be 3 zeros and then 2 times a 3, so 6,000 shares. That's too many, so we're going to go and just limit that to 4,000. Let's go ahead and now switch back to our command line, bring up that command again, and then let's change the shares per gigabyte to something like 5. So we would expect 5 times 100, so 500 on the one and 1,500 on the other as a minimum. Now let's see what that actually looks like. Okay, so here we've executed it successfully. Let's go back to vSphere client. I'll refresh that by exiting out and coming back in. Hitting the OK button, Resources tab, Disk. Okay, so here we can see not quite what we might have thought. So what ends up happening is the minimum starting value is 2,000. And then we added the 500 for the one on top of that 2,000 and the roughly 1,500 or 1,600 for the other on top of 2,000. So that's why the root disk ends up at around 2,500 here, and our data disk ends up at about 3,600. So you can see that in a production environment or even a development environment, as people are spinning up new virtual machines whose root disks are ending up on these data stores and whose data disks are also ending up on these data stores, they're going to have the default SIOC values initially. So what I would recommend is that you run a cron job or something that wakes up every minute or so and issues, I'll switch back to it, issues this command to CloudStack for the data store in question, or the primary storage in question. In this case, since we're dealing with VMware and SIOC, our primary storage in CloudStack equates to a data store. So as we have changes to our data store, volumes are created or resized, we would need to rerun this command to have all of those changes taken into account and have the SIOC numbers updated properly within vCenter Server. So my recommendation again would be to run this command on each of your relevant data stores on whatever interval you feel is necessary, maybe a minute or two. The way you would control whether you have, say, a platinum or a gold or a silver tier, the way I would recommend that is you create a SolidFire volume, maybe give it, regardless of tier, let's give it, say, 15,000 4K IOPS as its minimum value. And maybe for the platinum tier, we create those volumes at 2 terabytes, perhaps 4 terabytes for the gold tier, maybe 6 terabytes for the silver tier. So the sizes vary on those tiers, but the performance level for each of the underlying SolidFire volumes is the same. And then when you issue this API call into CloudStack's SIOC plugin, you would specify perhaps for the platinum tier that you want to give 10 shares per gigabyte, maybe 5 shares for the gold. You can basically play around with it that way, or maybe it's 20 shares per gigabyte for the platinum, 10 for the gold, and 5 for the silver. But that's how you would basically be able to control the shares and also the limit IOPS in different ways based on the targeted tier, platinum, gold, silver, and basically leverage a combination of SolidFire quality of service and VMware quality of service, VMware's quality of service being called SIOC, or Storage I/O Control, which is the main topic of this particular video. So thank you.